In this video, we are going to discuss about Cayley-Hamilton theorem. It's an important theorem under matrices. The statement of Cayley-Hamilton theorem is, every square matrix satisfies its own characteristic equation. This is the statement of Cayley-Hamilton theorem. Based on the theorem, now we can see a problem. Verify that a matrix A is equal to, it's a 2 by 2 matrix, first row 1, 2, second row 2 minus 1, satisfies its own characteristic equation and hence find a power 4. So the problem contains two parts. First one is verification of Cayley-Hamilton theorem, and using that theorem we can find a power 4. So the question contains two parts. Now we will see the first part of the question. For every matrix we can find a characteristic equation. So the characteristic equation is mod A minus lambda equal to 0. That is nothing but in the given matrix, leading diagonal elements we have to subtract by lambda, then we have to expand that. So we can get the characteristic equation as lambda square minus 5 equal to 0. So how to use the Cayley-Hamilton theorem for the characteristic equation means, instead of lambda we can replace lambda by a. So a square minus 5i equal to 0. So we have to verify that a square minus 5i equal to 0. If it is equal to 0, we can say that the given matrix satisfies Cayley-Hamilton theorem. So finding a square, A matrix is given, we have to multiply A into A, we can get A square matrix, minus 5 into I is nothing but identity or unit matrix. So we can make it as minus 5 into 1001. So multiply and minus 5i, we can get the answer as 0000. So hence we are getting a 0 matrix. Therefore A satisfies its own characteristic equation. Now in the question, the second part of the question is find a power 4. Finding a power 4. To find the a power 4, we have to use only the equation, that is a square minus 5a equal to 0. That equation you have to multiply by a square, so that we can get a power 4 minus 5a square equal to 0. Now we can keep the a power 4 in the left hand side, make it that 5a square into the right hand side, substitute the values of a square, we can get the answer as a power 4 as 250025. So using Cayley-Hamilton theorem, we can find a power 4 like this. Instead of a power 4, we can find a inverse also. So in the case of a inverse, what we have to do? We have to multiply this equation, that is a square minus 5i equal to 0. Multiply this equation by a inverse, so that the equation will be reduced as a minus 5a inverse equal to 0. In that case, we can keep the a inverse in the left hand side, take the remaining terms to the right hand side, so that we can get the answer for a inverse. This is the problem under Cayley-Hamilton theorem. So using Cayley-Hamilton theorem, only we can find a power 4 or a inverse. So this is the example of Cayley-Hamilton theorem. Thank you for watching.